favorite to solve math?
Me!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to the elementary edition of Count on Us. I'm Sherry Sternberg.
I'm Nina Jax.
And we are here usually to help you with your homework, but today we have a special broadcast because today what we're going to do is practice some fast test skills and review.
That's great because
Okay.
actually this week students are taking the FAST test. This week
Absolutely.
and next week.
So what we're going to do is go over some problems and some skills that you may need for that fast test. And we're going to start out, though, with one of our favorites, which you're not going to see this in particular on the fast test. This is our 24 challenge. But we want to start out with the 24 challenge because we do start out all our shows with our 24 challenge. But the skills you need to do the 24 challenge are skills you need for the fast test.
Absolutely.
So, for example, let's start with this card. Well, these are all the same numbers.
They sure are.
And
Those
they're
look
all
like
sixes because our 9s are usually filled in. So this card is actually way too easy because I see 4 6s. And right away in my mind, I know where we're going with this.
Do you think it could be 4 times 6?
Well,
or 4 plus?
right.
I'm sorry, 6 plus 6.
There we go.
Plus 6 plus 6?
So let's use that strategy that Miss Jax just did because here's how the challenge 24, if I can open up my marker. Let's get this
If
open.
you push that little...
There we go.
There you go.
All right, so we have 4 6s, 6, 6, 6, and 6. And remember, the goal of the challenge 24 is to make these 4 numbers using addition, subtraction, multiplication, and or division, any of these 4 computation signs, to make these 4 numbers, using them once each, equal 24.
Okay.
All right, so that's the goal. And you already gave us the answer to this one, because this one we're going to say 6 plus 6 equals 12.
Okay.
And 6 plus 6 equals 12 again. And then 12 plus 12 equals 24.
24.
So we have
All right.
used all of our 6s. So that was an easy one. And actually, what we also like to tell our students, there's usually more than one solution. So I'm going to revisit this one in a little while. But I want to come to another one. Let's look at this. 7, 2, 4, and 4. So we need to make these 4 numbers, which don't just add up. 7 plus 2 is 9, plus 4 gives us 17, doesn't it? So we need
not
to
always
do
addition.
Exactly.
A lot of times students call in and they think, oh, I'm just going to add everything, but it's not always addition.
And it is a great strategy to start with just adding the 4 of them, because you
Yes.
don't want to miss that and work too hard around it. So, because mathematicians like to be efficient, so we want to be quick and easy. Try it. If it works in addition, great. But when it doesn't, here's a strategy that I like to use, and 5th graders in particular, here's what you need to know. What you want to do is find factors of 24.
Okay.
And then figure out if you can use those factors to help you get to these numbers.
All right, that's
So,
interesting.
I use the Texas T. Have I taught you the Texas T?
I remember the first time I did the show with you, but guess what? I forgot the Texas T.
That's why
Could you
practice
show me again?
You got it. You
Okay.
got it. And you guys have it too. So here's what we're going to do with the Texas T. You put the number you want to find the factors of. And again, 5th graders, finding factors is a skill you need for the FAST test. You put it on top of a T. There we go, Texas T. And you start out by using your counting numbers. I had a class of kids and I said to them, what's the smallest counting number? And they said to me, 0.
Oh, no.
And I said, count for me. And they said, 1, 2, 3.
So they started with 1.
Exactly.
Okay.
So the largest counting number is 1. The smallest counting number is 1. So you start with 1. Any number times itself is going to give you that number.
Okay.
So we always have 1 in itself as our first number on our Texas T.
Okay.
Now, the next thing we do is go to the next counting number, which is
2.
We list our 2, and we say what number, we're thinking in our head, what number times 2 is going to give us that 24 that we want, because each of these are going to equal this 24.
Okay, let's put 12 there.
12, and when you know your facts, it makes it easy, not only for the challenge 24, but for all of your multiplication. So 2 times 12, and we knew 24 has 2 as a factor in another number because it's an even number.
Yes.
So we look at the ones place. That's our divisibility rules.
Yes.
When we any number that's even, we'll have 2 and another number as a factor.
Okay.
So the next counting number is
3.
3. So we're just going to count up what number, or is there a number times 3? Now we're looking at it kind of like algebra, a missing number here.
Okay.
What number times 3 equals 24?
8.
8. Notice that as we get these numbers bigger, these numbers get smaller.
Oh, I like that. Okay.
So lots of patterns
like a
happening as
pattern,
well.
okay.
All right, so 3 times 8 equals 24. Next counting number is 4. What number times 4 equals 24?
6.
6. Again, we're getting bigger here and smaller here as our numbers are getting closer to the center. Next counting number?
5.
5. Now, 5 times what number equals 24?
5 times no number unless it's a decimal somewhere, some type of probably repeating decimal.
Now,
or
use your
non-terminating.
disability rules.
Yes, with divisibility, the rule for 5 is the ones digit will either end in a 5 or a 0.
Which it is not, so we know
not.
no number goes here, so this one is not a factor. Okay. Now, here's the part where we have to remember the step. What's the next counting number?
6.
We already have 6 on the other side, so we know we're finished.
Okay.
We're finished with this portion. So we're done. There are no more factors. The next thing we do is look at who has a partner. Partner, 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 no partner.
Okay.
So our factors, and if we do them in that horseshoe from least to greatest, are 1, 2, 3, 4. If we want to list them, let me make a little bit of space
See
over
if I
here.
can try to
Let's come right under here.
1.
1, okay, even better. We have it done another color. So we have 1, 2, 3, 4. Come to the other side. 6, 8, 12, and 24. All of these are factors.
Okay.
Okay. Factors are numbers that we multiply to get the product.
All right.
So they're always smaller than the product. Students confuse factors.
And let me guess, multiples.
Yeah. Okay.
Yes.
You know our students.
Yes.
And multiples. And I always get confused as to why they get confused, because factors are the numbers that we multiply to give us, but multiples always get bigger.
Okay.
So, for example, if we went with multiples of 24, we're going to start with 24 and get bigger from there. Okay. Our factors of 24, and maybe we'll use that second color that you had here, if you want to relist our factors we just did.
Absolutely.
1, 2, 3, 4, 6, 8. Oh, we forgot the 12.
Oops. Look at that. I forgot one. Do we have an eraser?
I have this one. 12 and 24.
12 and 24.
So our factors of 24 start with 1, end with 24, and all the numbers are in between. Our multiples, think multiply.
Okay.
So 1 times 24 is 24. 2 times 24 is, and another color might be a good idea. So 48. 3 times 24 would be?
Okay, well, I'm going to have to add my 24 plus my 48, if you don't mind.
I don't mind, but that would be, let's go to 4 for that, okay?
Okay, so if I'm going to multiply 24 times 3, well, let me go ahead and do 24
I like it, go into a workspace.
times 3. Let me use a workspace over here just so you all at home can see this. 3 times 4 is 12, and I'm going to carry my 1. And 3 times 2 is 6, plus 1 more gives me 7. Okay, so 72. You know what this makes me think of? What? There are 24 hours in a day. Oh. And I know when I used to teach 5th grade and 6th grade, I would have my students think about, well, how many hours would it be if you had 3 days or 4 days or 5 days?
So kind of look what we're doing, a function table.
Oh, absolutely.
Isn't that nice?
Look at that.
Again, something they need to know, function tables. If they give you numbers and you need to figure out missing numbers, they may give you that 4 and want a number here. They may give you a number here. I guess that one should be in blue, but and want to know what number goes there. But
you're right,
again,
and they would have to figure out the function. And this is definitely a skill for FAST. I don't know if it's coming up this week, but it's definitely a skill for FAST and probably for MSA as well.
So you used the multiplication strategy.
Yes.
If each number we're doing up here, we're kind of multiplying by that 24. So this is 1 times 24, 2 24s, 3 24s. So 4 times 24.
Let me go ahead and use our...
I already actually gave it. I wrote it in the wrong spot.
Okay.
I'm going to erase the number and move that over. Wait for you to figure it out.
Okay, so at home you could try it this way. So 4 times 4 is 16. We drop the 6 and carry the 1. 4 times 2 is 8 plus 1 more is 9. Look at that.
96. Now, one strategy was to do that multiplying. Another strategy, and this is a great strategy when you don't know your facts. 2 times 24 was 48.
Okay.
So 4 times that would be double. So if we just come over to the 48 and double it.
You're right. And 8 plus
8 is 16. 4 and 4 is 8. Plus 1 is 9. Same answer.
Good.
Another strategy.
Okay, another way to do that.
And certainly the least favorite strategy, but you could, if we come over to her, and she knows where I'm going.
Yes.
Go ahead.
Okay, so if you are asked to find what your product would be if 5 is here, if the input is 5, what's your output? You could, and students want to say, well, I could just add 24 5 different times. And then you'd have 24 plus 24 plus 24.
I'm going to read the newspaper while you're doing
24 plus. Okay, you see where I'm going with this. You could do that, or if you're realizing, well, I know we did the multiplication
why don't you do
earlier.
that? I'm going to come over here and do the multiplication, and let's see.
See who gets there faster.
All right, wait a minute. Let me at least get it written, because you have yours written. All right, so 24 5 times, 24 5 times.
Goodness.
Ready, set,
go.
I know we're quiet. I'm done.
Oh, that's not fair.
What do you mean that's not fair? I used my skills, my strategies of multiplying. You said 24 5 times. Why do I want to add it up?
So do you mean this is quicker than adding everything? All I have right now is a 0. I see a 0 as a partial product. I'm going to say partially, as the answer here, but I was thinking, let me see, 1, 2, 3, 4, 5 times 4 is 20, or some kids would even do 4 plus 4 is 8, and 8 plus 4 more is 12. That would take too long. You did this so fast.
And you know what? We're not saying this is wrong. We're saying this is more efficient, more effective. Mathematicians like to be both. They need to be accurate, but efficiently accurate. So
I'm going to finish this if you all don't mind.
Absolutely.
Okay. And then I could say 2, 4, 6, 8, 10, 12. And guess what? We have the same answer, 120 here, 120 here. But Ms. Sternberg did hers in less than, I would say, 2 seconds.
All right. So, and actually there's a third strategy here.
What's
the one
the third
we just
strategy?
did here. The third
Okay.
strategy would be to say, since we're already using our table, well, 5 of them would be 2 plus 3.
You're right about that. So you could add 48 plus 72?
Exactly, and that should get us to the same place. Let's see.
Okay, 2 plus 8 does give us 10. So I'm going to use 1/3 color here. So we're going to put a 0 here and carry. Ooh, I have to hurl my pen the right way. 0 here and carry the 1. 7 plus 1 is 8, and 8 plus 4 is 12. Wow, so that is a third strategy.
So, and that's a skill in itself. Having multiple strategies for being able to solve a problem. Certainly use the one that works best for you. Hopefully your teachers are giving you multiple strategies. The key is you want to become efficient, which means quick and accurate. That's what efficient means.
Yeah, especially when these kids are timed nowadays.
tests.
The tests are timed, and you want to make sure you're working quickly. But like Ms. Sternberg said, efficient. So your answer is correct, but you're still working quickly. And then if it's a BCR, you need to be able to explain what you did.
And so you could explain any of the strategies you used to justify what you were thinking and how you solved that problem.
Absolutely.
All right, so we started this out First of all, again, multiples always multiply.
Okay.
Just attach that. Multiples mean we're multiplying, so the number you're starting with always is your first number, and we get bigger from there.
Okay.
Factors are what we multiply to get that number, so they're always smaller. That number and everything else is smaller. 1 is always a factor and itself. And let me ask you, I'm going to try and catch you. I don't have any students here, but let me ask you, if a number has, let's come over here, only 1 and itself as factors, it has a special name.
I think it's prime, but I just need to be sure.
Well, you are sure because it is prime. So any number that has just 1 in itself as a factor is a prime number. And then if it's not prime, which means it has more than 1 in itself as a factor, it is called
Composite.
composite. Okay? So prime, you're in your prime, you just have 2 numbers, 1 and itself, composite, and every even number except for 2, because 2 is such a small number, it only has 1 in itself. But every other even number, you're going to be able to divide by 2, so it's going to have 1, 2, and itself, plus other numbers as well.
And I'm glad you brought up 2 because I was going to ask you to go over that. A lot of times students automatically think that 2 is composite just because it's even.
But it's
so I'm
such
glad
a small
that you said
number.
yes.
It just has
Doesn't
1.
have room for anything else
Nope.
except 1 in itself.
There it is in my Texas T. The next counting number after 1 is 2. We're done. 1 and itself. Now, we started all this with our factors. Let me find our factors. Oh, they're on the back of this.
Okay.
We found all our factors because I said this was going to help us to do the 24 challenge, if you remember way back then.
Okay.
So let's hold this here, and we want to look at, let's use this eraser,
Okay.
and let's put up 2, 7, 4, and 4, which was the card we started with.
Okay.
So now we're wondering, or I'm wondering, this is how my strategy. Again, multiple strategies, what works for you might not work for me and vice versa. But what I like to do is see, is there anything I can do with these numbers to get to some of these partnerships?
Okay.
Can I get to a 4 and a 6? Well, I already have a 4.
Okay.
Can I do anything to make this a 6?
I see that you could probably add 2 of those numbers to make a 6.
Okay.
You could add 2 and 4.
All right, 2 and 4 will give me a 6. So then I'll have a 6 and a 4, which I need.
But then you still have the 7
Exactly,
here.
I have an extra number.
Okay.
So what about if I see a 2 and a 4, and 2 times 4 gives me an 8. The partner for 8 is 3.
Yes.
If I make these two, a 2 and a 4, make this an 8. Let's bring this up here.
Okay.
If I make this an 8, is there anything I can do with a 7 and a 4 to get a 3?
Yes, I think you could subtract 4 from 7.
All
so
right.
7 minus 4 gives
So
you
now we're seeing,
I
so here we go.
see.
So we're going to do our first step, use our 4 times the 2, and that's going to give me my 8. I use these 2 digits.
Okay.
The partner of 8, and gosh, if you can learn the factors of 24, you're a leg ahead of everybody else, because as soon as I hear 8, you know,
you need 3 as
you
your
know you need
partner.
3. Up, 7, 4. I'm seeing it in my head. 7 minus 4 is going to give me the 3. And then
8 times 3 gives us 24.
exactly.
Wow, okay.
So I'm going to ring the bell for myself. Or for us. We work together on that one. But yes, exactly. So that gives us a 24. And again, the strategy of getting to factors that have a partner really helps you figure these out. I played with some students, the 24 challenge. Have you ever played where you put down the card?
Yes.
Okay, let me tell you. The students that enter these contests that are in the 24 challenge, you put that card and they're slapping.
Oh, and they're serious.
Because
they are
they
serious.
have the patterns in their head. I'm pretty good at this game, but these students, 5th, 6th graders, you put it down, they see 2, 4, 8. They know it's an 8. They know they need a 3. They see the 7 and 4, and immediately they're slapping these cards.
Yes, absolutely.
And that's what you want to be. You want to be you know, so quick with your math that you're so confident and comfortable that you can just solve any problem.
Well, if you ever visit Gwynn Park Middle School, Mr. Belton is a teacher there, and he has his kids do 24 as his warm-up, and they are, yes, they're quick, they're efficient, and I know it has helped them with their multiplication and their other factors.
Excellent. So why don't we take a break from factors and math and multiplication for a minute? How about we do a little, maybe a little Pascal's Penguins?
Okay, not a problem.
Let's look at that.
And this looks like it came
Kind
from...
of tiny, huh? Well, I hope they can see.
It looks like they may be able to see, hopefully.
Yes. All right, great.
This looks like it came from the winter packet.
So students may have seen this before.
Yes, and this is actually going to help you with the review to make sure you had your answers correct. Okay?
So Pascal is a mathematician.
Yes,
Pascal has had a triangle. And this triangle is set up so that the numbers do something special. Want to tell us about what the numbers do?
Okay, well, it looks like here, it looks like the numbers, even though we don't have any numbers at the bottom, we're going to fill this in a special way. The numbers below actually give us the numbers above. And if we can look at the triangle more closely, as I talk about it, you'll see exactly what I'm talking about. Okay, so with the Pascal's triangle, we start with a 1 at the top, and then the next two numbers happen to be 1. But let's look here at this third row. In the third row, I have a 1 on this side and a 1 on the other side, but in the middle, I have a 2. So I'm wondering where this 2 came from. Well, in order for me to get the two numbers above will, if I add these two numbers, and if I look at the number directly between them, that will give me my sum. So let me go ahead and see if this works. 1 plus 1 gives me 2.
Oh, I like it. So there's a nice little pattern going on.
Yes, definitely some type of pattern. So we're going to continue that down the triangle to fill in the rest of the triangle.
How about another color?
Okay, absolutely. We can use another color. Will this show up blue? Because right now I have...
Right for you. I'll be your... Have you ever done... there's a cooperative learning strategy called Boss Secretary.
No, I have not.
Oh, it's one of my favorites. And I do it with my students a lot. So I become the secretary, and the students love to be my boss.
I'm sure.
And they do it with partners as well. But I'm going to be the secretary. You're going to be the boss. I only write what you tell me to write.
Okay.
But I'm a good secretary, so if you mislead me or I don't think what you're telling me to write is correct, we're gonna talk about it.
Okay, not a problem.
All right, so you told me that 1 plus 1 is 2, and that 2 is already there.
2 is already here.
So we're good. All right, so what would you like me to do next, boss?
So let me see if I can find out where this 3 came from. If I take 1 plus 2 and add it up, I'm going to get 3. So 3 is here. That's going to help me fill in this triangle over here. 2 plus 1 is also 3, so I'm going to ask you to go ahead and put a 3 there.
And I understand that you're saying the triangles, the 2 above, kind of make a partnership and form the third point in the triangle?
Absolutely, and that third point must be the sum of the 2 at the top.
It's the sum. So I will then agree that 2 plus 1 forms the sum of 3.
Okay.
I like it. So again, the pattern continues: 1, 1, 1, 1, 2, with a 2 in the middle. You know what these are also?
What?
Palindromes.
Oh, okay.
So I think we're going to see a palindrome. Palindrome. Palindromes are numbers or words
that have the same beginning and ending, or are the same whether they're frontward or backward. Okay.
Wow, you got it. Wow. W-O-W.
Look at that. Wow, it's a palindrome. I love it. So we're also giving you a little fast for Rila, for reading language arts.
Tell your mom. Tell your mom. Or your
Could
dad.
we tell Dad? There we go. So palindromes, once again, no matter which way you write the word or the number, it's going to be the same. So wow, we have a W-O-W, and if I write it backwards, it's still W-O-W. Same thing with mom and dad. Okay, so let's look here. We have a 1, 2, 1 and 1, 2, 1.
Excellent.
Oh, 1, 3, 3, 1 and 1, 3, 3, 1. That helps me because I don't have anything here. So if I have a 1 on this end, I think I need a 1 over here.
And as your boss, I mean, as your secretary, I'm going to say that's right. I like that. Plus Plus, if I look at the patterns coming down, there's all ones coming diagonally. So
Look
I
at
like that. Okay.
I love patterns. Okay,
Me
patterns
too.
help us out. All right, so I'm going to go ahead and continue with the theme of this pattern, where we add the two numbers above and then kind of create a triangle, and then our sum is here for the third point. So 3 plus 3 gives me 6. Let's go ahead and put a 6 there.
I like it. I agree.
Okay.
So I'm writing 6. Again, the points of the triangle. Point 1, point 2, point 3 is our sum.
And then if I add 3 plus 1, that gives me 4. And it will go with our palindrome, like you said.
1, 1, 4, 4.
4.
I like it.
And
That's a double
6.
check. We're kind of checking our work as we do it.
Yes, this is great.
All right, what's next?
Okay, well, even though we don't have anything
Nothing.
here, we still know that we are going to have a 1 on each end. So let's go ahead and put the 1 on that
like it.
left and 1 on the right. All right, now I'm going to go ahead and use the two triangles above to give me a sum here. So 1 plus 4 gives me 5.
All right, I'm agreeing, so I'm writing.
Would you like to go to this one, or should we just continue across? What do you think?
Oh, well, gosh, we could really do either one
We
because
sure
we have
could.
the pattern here, we have the Wow.
Let's go to this side.
Okay.
Okay, so we'll go to this side.
Okay.
4 plus 1 is 5 again.
All right, so we're matching. I like it.
And then we're going to fill in these two little guys here. So 6 plus 4 gives me 10. And it gives me another triangle. That's the third point. And 4 plus 6, oh my goodness, gives us 10.
1, 5, 10, 10, 5, 1.
1, 5, 10, 10, 5, 1. Look at that. It
So our
does work.
palindrome works, our pattern works, Pascal's penguins work. Now there's some questions they want to know too.
Okay.
Because, you know, it's one thing to be able to do the math. It's another thing to be able to communicate or explain the math you did. So let's see what they're asking us.
Okay, let's go ahead and read what this says. It says, fill in the missing penguin numbers.
Did that?
Think about the pattern. And we did think about that. We actually thought about it and we discussed the pattern.
Absolutely.
How are the numbers in each row determined? And we kind of talked about how they were determined. The two numbers above gave us the final point for the sum below. Now, here's where the tough part, it may not be tough though. Sometimes we understand what we want to say, but we have trouble articulating, meaning that we can't really get it out and explain to someone else why our answer is correct. So let's see what it says. Explain why your answer is correct using words, numbers, and or symbols. And then there's a hint. The hint is start at the top and work downward, okay? So we did get a chance to start at the top. So we did follow those directions. We started at the top and then we did work downward. But now we must think about why the answer is correct. So let's go ahead and look at our Pascal's penguin and see why the answer is correct. Okay, well, based on the pattern that we followed, we see here that we have a 1, and we know that we're not adding 1 to anything.
I'm
Yes.
sorry. Are you just thinking out loud right now?
Yes,
or do you
I'm
want
thinking.
Me to be ready?
I'm
Great.
thinking out loud.
And,
yes.
and you know what? That's so important to do your thinking first before you start writing and then have to go back and erase it all. Get your thoughts together, and then I'll write when you're ready.
Okay, all right. So as I'm thinking about this, I know that we did some addition. And in order to fill in the numbers, we had to add the two numbers above in order to get the number directly below. Now, the 2 was given to us. Since this 2 was already given to us, we used the thought that we had. We used the rule for the pattern, which we thought was the two numbers above would give us the third point on the triangle. And we tested it out to see if it would work, and it did work. So the 2 was given to us, and that helped us out, okay? So we were able to also go to this 4th row here and check to see if it works, because the one thing I tell students is just because it works one time doesn't mean that it's going to work all the time.
Point.
So when you have a pattern, you need to make sure that it works at least 3 different times, and then, you know, you can make sure your pattern is secure. Okay, so according to this, the way we felt that we should fill out the penguins did work. So let's go ahead and take a closer look again, and then we can write our answer. Down here, the 3 was also given to us, so this helped us out. We went ahead and checked to see if our answer was correct. 1 plus 2 does give you 3. So you have your 1 plus 2 here, and then it does give you 3. So we just went ahead and continued with this. So Our answer is correct because we followed the pattern, and patterns do repeat.
Okay.
So I'm going to ask you to give me some help here because it does say we can use words, numbers, and or symbols. I would like to use words and numbers.
Okay.
Okay. Let me see. It says explain why your answer is correct. Well, we can start off with my answer is correct. Now, let me ask. I'm wondering if we are allowed to do that anymore. And
Yeah.
I don't think we do that anymore.
We don't really do that.
They
Our
want to get
students
just to the answer.
Get to the nitty gritty.
Get to the answer.
We'll
Okay,
keep using
well,
that
let's-
word efficient,
Okay.
and that's extra words. I mean, if we're explaining why our answer is correct, we don't have to tell you. We know it's correct. So
Okay.
let's just
let's go ahead and start with the math.
Okay, exactly.
Okay. 1 plus 1 equals 2.
Okay, so you want me to just say 1 plus 1 equals 2? Or do you
Well,
want me to
we
say
can
I
explain
added?
it. Well, we can do that. Well, let's go ahead and do some of the math and then give the explanation.
go for it.
So 1 plus 1 equals 2.
1 plus 1 equals 2.
Okay. Now, I added,
I wonder if what might even be better is to show
to show what we did.
1 and 1. Show it that way.
Okay,
1
and then
plus
maybe the
1.
arrows.
Exactly. Let's do it
Okay.
that way. 1, there's an arrow. Yeah, let's put some
Okay.
arrows there. So 1 plus 1 is 2.
Okay. And what else did we fill in? We filled in this 3 over here. 2 plus 1 is
2
3
plus 1
equals 3.
equals 3.
So we're showing where we got this answer from.
Okay.
3 plus 3 equals 6.
3 plus 3, and we'll put some arrows here, equals 6.
3 plus 1 equals 4. And I'm going to stop there.
Okay.
Okay. Now, my understanding is as long as you explain some of it,
Okay.
then the rest of the pattern should be able to flow so we can understand
Okay.
the viewer or whoever is grading your
And,
paper
and,
should
and
be able
what
to
kids
understand.
what our students need to also understand, a lot of times we say, oh, you know what I mean. Well, your teacher, your classroom teacher, even the teachers in your building, they're not even the ones who grade your tests.
It's someone else somewhere
Who
far
doesn't
away.
know you, who doesn't know your handwriting, who doesn't know your thinking, who doesn't know what you mean. Oh, you know what I mean. No. All they know are the words that they're reading or the symbols and numbers that they're seeing.
Okay.
So
Now,
explain it.
this is where our explanation is going to come in.
All right.
So I added the 2 numbers directly above the sum.
So I added the 2 numbers above to give me the sum.
To give me the sum.
Okay, to give me the sum below.
Okay, the sum below.
Okay.
All right. And then here we have 4 examples here. So this gives us the 4 examples for the ones that we filled in.
Okay.
Now, we can also continue to say the rest, we filled in the rest of the pattern or the rest
I like
of
that we're using that word pattern.
the rest of the pattern.
I continued
My
using
pattern.
that. Okay. I continued using
The same strategy.
that strategy to complete
or complete the pattern.
the pattern.
We also did some checking. Didn't we go ahead and check?
I checked using, can we say the palindromes?
Sure.
I checked using the palindrome because the row had the same numbers from left
To right.
to right. And I know my writing's not that big, that's why I'm saying it out loud because I'm not sure if you're seeing it. And right
To left.
to left. And you know what? Anybody who's reading this, we have numbers with the symbols here. We have an explanation of how we did the pattern and continued it. And then we had how we checked it. This is a 2.
Okay.
This is full credit.
Well, let me also say that if you have time, you could go ahead and do your 4 plus 1 is 5. Or what we could have done was maybe a few from the top and maybe some from the bottom. That way we could show that, the entire triangle was filled in using the same strategy. So we could go ahead and say 4 plus 1 is 5 and 6 plus 4 is 10, just to give the reviewer.
And I agree with that, but you know, we have 4 examples. We have words to explain our example. We use the fact they asked about a pattern here, and we use the word pattern to explain. I think we covered it.
Let me ask you: are kids allowed to underline and highlight certain words now?
They are.
They are. Okay.
Everything is. Remember, there's a box.
Yes. Whatever's in the box.
As long as you're in the box,
okay.
That's what they'll look at. Anything. So underlining and highlighting is great. So I think we did a lot with that problem, and I think right now what we're going to do is take a break. But before we take a break, what we're going to do is tell you that if you have a problem that you'd like us to solve in the second half of Count on Us, what you can do is email it to us.
Oh, okay.
And then we're going to use the technology of an iPad and work through that problem and bring it out to you. So
isn't technology great?
It is. So you can see on the screen, email is COU@pgcps.org, and that COU stands for Count on Us. So take a quick moment if you have a problem and email it to us quickly, and they'll bring it out to us, and we'll try and get your problem on the air in the second half of the show. We're going to take a break, take a drink of water, refresh our voices while you're getting yourselves together, and we'll be right back.
All right.
From Samuel Ogle Middle School. Today's email question is from Nicole at Benjamin Tasker. Nicole says, my problem is 98 hundredths times 7 3/10. I don't know where to put the decimal after I multiply. Help! Well, Nicole, first you do basic multiplication. You do 8 times 3, which equals 24. You drop your 4 and carry your 2. Next you do 3 times 9, which is 27, plus 2 is 29. You drop your 9 and carry your 2. Next you do 3 times 0, which is 0, plus 2 is 2. Next we move to the ones column. Now we do 7 times 8, which equals 56. You drop your 6 and carry your 5. Next we do 7 times 9. 7 times 9 is 63. Plus 5 is 68. You drop your 8 and carry your 6. Next we do 7 times 0, which equals 0. Plus 6 is 6. So now we add. For a placeholder, we add a 0. 4 plus 0 is 4. 9 plus 6 is 15. Drop your 5, carry your 1. Next we do 8 plus 2. 8 plus 2 is 10, plus 1 is 11. You drop your 1, you carry your 1. Next we do 1 plus 6. 1 plus 6 is 7. Now we look at the problem. We see that a decimal comes before 3 numbers in this problem, which means in the answer you bring the decimal over 3 places and you get an answer of 7 and 154 thousandths. Well, Nicole, I hope that was helpful. That was the email question of the day, and I'm Cameron Jenkins from Samuel Ogle. Bye.
Soccer. All across America, it's how kids get fit and have fun. Join us. Go to usyouthsoccer.org.
the elementary version of Count on Us. I'm Miss Sternberg. This is Miss Jackson. We are happy to be here, and we're happy to help you review some skills that you will need for the FAST test. Before break, we also told you you can email us with some problems, and we got a problem already.
We did get a problem.
So why don't we go right to it? It's kind of like an algebra problem. I love algebra. You said you love patterns. Our friends think we're so nerdy because we like math. But math is so cool.
Math is cool.
It's cool. I love it. So why don't we look at the problem? This was sent in from Madison.
Okay, Madison.
Not Wisconsin. I'm just saying.
Was it sent in from a student named Madison?
Yes, it was.
Okay.
All right, so why don't you tell us about the problem?
Okay, it looks like here Madison's question is, how do we solve for P? How would we begin to solve for P? What do you think we should do?
Well, you know what? Students see P and they get scared. They think algebra. Parents think algebra and they panic. And you know what I think? Watch, here's what I think.
What do you think?
63 minus blank, a box. Like we do in kindergarten, first grade, we put a box in there. What goes in that box?
So do you think it just eases people when they see the box instead of the letter?
I think we go from box, we transition to maybe a blank.
Okay.
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 And then maybe we move to the letter. And if I put an A here, does that make a difference?
No, it doesn't make a difference.
It doesn't make a difference. Whatever letter we use, it doesn't make a difference. So don't let the blank, the letter, the line,
the
the
variable.
box, that's such a good word. Variable. The variable. Don't let it scare you. Parents, don't let it scare you either. We can figure this out. So how do we do that?
Well, let's see what we have here. Let's go ahead and read what it says. It says 63 minus P equals 19. So that means that we are taking something from 63 in order to end up with 19 as our final answer. So let's first talk about what P could be. What could this variable represent?
Let's put, since her problem had P, let's leave it at P.
Okay.
But knowing it could be A or any other letter.
Okay. All right. So let's talk about what we could have here. Well, we have 63 minus P equals 19. How could we figure out what P could be? Let's go ahead and look at the operation that we have here. Okay. We could also use, we could also use fact families in order to figure this out. There are some different strategies, so let's look at a few different strategies here to find out what P is. Now, this operation is a subtraction. So in order for us to find out what P is, we could do a couple of different things here. Now, we know that our final answer is 19.
And that was going to be my question, or my comment. 19 is less than 63, and here's my whole amount. If we look at part whole,
okay.
So if we look at 2 parts are going to equal the whole of 63,
okay.
And I have 1 part.
So this is the part that's missing.
Okay, so it's a missing part, and I know that the total part is the biggest part, which means this tells me P is going to be less than 63.
Absolutely.
Okay.
So we know that P is less than 63. What could we do to find out what P is? Well, Ms. Sternberg went ahead and told us that 63 is the biggest part. So that means 63 is our total, right?
Correct.
That gives me an idea here. If 63 is the total and 19 is a part of that, could we maybe take 19 from the 63 and see what part is missing? Could we do something like that?
Absolutely.
I wonder if we could do that, because that may help you all to see better where we're getting the answer for our variable, okay?
And you know what? Just for our younger students who might be watching, if we look at our fact families, when we look at a subtraction problem, if we look at 9 take away, now because of our younger students, I'm going to say blank. 9 take away blank equals 6.
Okay.
Okay? So to figure out this blank, if we look at our fact families, we know that
there are always 3 numbers that go together, right?
3 numbers. So what number is going to go here that these 2 are going to add to give me the bigger number? So I also need a 6 plus blank equals 9.
Okay. And there are always 3 numbers that go together. And the number that's missing here is a 3.
And exactly. 6 plus 3 equals 9. So if that 3 goes here, blank plus 6 equals 9.
Does the 3 also go there?
Same thing.
Does that mean the 3 goes here too?
You got it.
Wow. So this is how the fact family could work as well.
And one more. 9 minus the 6
would give us
gives us that same blank 3.
Okay, good. So we know with fact families we always have 4 equations.
And as you get older, obviously you're not going to do all these problems, but here's what you need to think about. 9 minus the blank equals 6. We can take this equal sign, the number after the equals, bring it in here.
Okay.
And, subtrahend and bring in I don't remember which is which at this moment, but this number, if we take it from 9, gives us the answer.
Okay.
Well, that's exactly what you just said. What if we subtract the 19? We're subtracting the 6. You're going to want to subtract the 19.
And this is where the fact family comes
Exactly.
in. And I like the fact that you went ahead and you showed them the box again, because we didn't use a variable here. And I know with the younger students, a lot of times they don't start using variables until maybe 3rd or 4th grade, the variables are introduced. And sometimes we have a box or a little blank, like you said, a little line. So this is just like our box or a line. So what we're going to do here is go ahead and use our fact family. Well, 63 is here. We have a 19. We need to figure out what number is missing. And in order to do that, we're going to do some subtraction.
Excellent.
Okay? Okay, so let's go ahead and subtract 63 minus 19. Would you play secretary for me just because it's hard to reach?
You got it.
You want to do blue or red?
It doesn't matter. I'll use the black.
Okay, there we go.
All right, so 63, do you want me to write it under or across?
If you would write it under, that would be perfect. And I know a lot of times you may see it written across. I always have my students rewrite it and write it under just to keep the numbers lined up. So let's go ahead and see what we can subtract. 3 minus 9.
Now you're going to get a lot of students who say you can't do that. You only have 3, you can't give me 9.
I think I have to regroup or borrow. We used to say borrow when I was in school.
Borrow, trade, regroup. They use all those words, but trading is the one I think they're stuck on now.
Trading is we're going to trade.
Yep.
I'm going to borrow a 10 from the 6 over here.
Okay.
So this 6, if I take a 10 away, becomes 5, and then I'm going to put my 10 in front of that 3.
And we could either put a 1 here to make it look like 13, or a lot of students cross it out and rewrite 13.
Cross it out.
Again, your preference.
Whatever is easier for you. So now we can do 13 minus 9. Well, 13 minus 9 is 4.
And again, just for alternate strategies, a quick count up. 9, 10, 11, 12, 13 gets me that same 4.
Absolutely. You're right. You could count up. Okay. So now we have 5 minus 1. We could count up, like you said, or you could just simply subtract 1 from 5, which also gives you 4.
All right, 44. So that 44, if we're looking at our part whole, goes here. And now we have 3 numbers, as you said, to make a fact family. So we could actually take this same card here and do the same exact strategy.
Well, let's go ahead and see if it works.
All right, so we're going to say 44 plus 19
equals 63.
63. We're going to switch them around and say 19 plus 44 equals
63.
63. And then we're going to bring that 63 over here, and we're going to do 2 subtraction problems. Doesn't matter which one I do first. 16 minus 19 equals...
63 minus 19 is 44.
Is 44. And notice she's not counting up or counting down at this point. Once you know your fact family, you're all set. You got all 4 problems. And now we're going to reverse it. 63 minus the 44
equals 19.
Equals 19.
All right.
Excellent.
So, Madison, I hope that helps you. And once again, when you have...
One more thing. We just want to make sure we know, identify what's P.
Okay.
Let's identify our P.
So, right here, this P, once again, we see it as a letter. It is called a variable. P equals 44. So, you want to make sure that you write that somewhere. P equals 44. And maybe I used to tell my kids put a box around it, just because there's a lot of work here. So you want to make sure that your teacher knows that is your answer. So P equals 44. So we want to just reiterate really quickly. When you see a variable, don't get bent out of shape. You can erase the variable like Ms. Sternberg did and rewrite it with a box, or go ahead and put a little line or just a blank space, and use your fact families to see what number could fill in that variable, what number could take the place of the variable. Okay, so
excellent.
Do you want to look at?
Can I show you one more strategy?
Absolutely.
In keeping with our theme of multiple strategies.
Okay.
Here's a strategy for this problem: 63 minus 19. A lot of students aren't fans of regrouping
Okay.
or trading, borrowing when you have to do that. Another strategy, again, use it if it works for you. Don't use it if it doesn't work for you. But what's 19 plus 1?
19 plus 1 is 20.
So if I took 63 and minus 20, what does that equal? Look how easy this problem is.
Yes, I could put my 3 here.
Why don't you do that one?
So 3 minus 0 gives me 3. And then 6 minus 2 gives me 4. Well, I have 43, but I remember we counted 1 up in order to, so we rounded up to 1, to the nearest 10, the nearest 10. So from 19, we did round up 1 and we got 20. So if I go ahead and do that, in order to make it easier so we don't have to regroup, we just have to remember how many units in between we counted up in order to get to 20. And there was 1 unit lagging in between. So I guess I would have to add that 1 unit at the end. Okay, so 43 plus 1 is 44. Okay, so is that the other strategy? Okay, I like that.
Okay, and look how much easier it made it. So this way, because we just had no regrouping to do.
No regrouping, not at all. We just had to remember, though, that we needed to add that 1 at the end.
If you don't have a good memory, not a good strategy for you. So you have to decide what works for you. All right, so we've done some multiplication, we've done factors, we've done multiples, we've done subtraction, we've done fact families. Why don't we move to some geometry?
Okay.
Let's do a little bit with geometry, and we're going to erase Madison's problem. And area and perimeter, no matter how often we tell you, we practice, we remind you, students, for some reason, you love to confuse area and perimeter.
They mix them up all the time.
I don't know why.
Well, we are going to work with some tiles here.
I love it. Square tiles. Area, squares.
Square tiles. Okay, well, let's go ahead and put them together. Do you want to do a perfect square first and then maybe a rectangle? Okay.
Whatever works for you.
All right, let's go ahead and do a perfect square first. So we'll do
when you say perfect square, what does that mean, perfect square?
That it actually has two factors that are the same.
Okay, so...
And the factors are... In this case, let's find out what that is.
Okay.
Okay. And it makes a perfect square. It gives you a square. So the two numbers that we multiply, we talked about factors earlier.
You know what? I'm just going to replace these two yellows.
I noticed that just now. Okay. I did see that as I was looking.
There we go. That's better.
So the two numbers that we multiply is actually the same number. You're just multiplying it.
Okay. So when you have the same length and width, the same two factors, we call that a perfect square. All right, so what are those numbers?
In this case, well, let's find out. Let's see how many squares we have going across and how many squares we have going up and down, like Ms. Sternberg said, length and width. Okay?
And these happen to also just be inches, because they're squares, but we could call them squares as centimeters. It could be feet, whatever unit you're using. We could call them square units.
Okay.
But again,
let's use inches for today.
Okay.
Okay, so we'll go ahead and use inches.
I'll record for you.
All right, so let's count across to see how many inches long. And if it's a square, the length and width, it really doesn't matter which way you do it. Okay, so let's count. 1, 2, 3. I have 3 inches going across the top.
So you just wrote 3. You told me to write 3 across the top, and I'm writing it on the bottom. Am I allowed to do that?
You are allowed to do it if it's a perfect square, because the 3 on the top is going to be the same as the 3 on the bottom. Because when we go ahead.
Am I allowed to do that if it's a rectangle?
It depends.
Oh.
If I counted the one on the side, let's say if I counted the one on the left side, you could not write the same thing on the bottom.
Oh, right, but my top and bottom would be the same.
Yes, absolutely. The top and the bottom is the same.
So I have a 3 here, and we said we're going to call them inches?
Yes, 3 inches.
So here's 3 inches here, and I'll just abbreviate, IN period.
Yep.
3 inches here, and because I know my opposite side, so top and bottom are the same, I'm going to write the 3 here. Don't have to recount. Again, efficient.
Okay, and let's go ahead and count on the right side, and I'm going to ask Ms. Sternberg to write it on the left. Okay, because we know with the square.
She said count, but I'm not going to count because when she said square, as soon as she said square, I know that all 4 sides are the same.
Yes.
So therefore, this is going to be my 3 inches. This is going to be my 3 inches. And if you remember earlier in the show, we can add 1, 2, 3, 4 threes, or we can multiply 4 times 3.
Okay.
Well, or we can have a contest again, and
we
I
can
win.
do both. But we can talk about that also. We know the formula for area of a square is side squared. So, which you said, you know, if you want to do the multiplication, you can do that as well.
So, area of a square is
S with a little tiny 2 up there for square, side square. So you could do 3.
Or it's still, let's also write this because it's length times width as well.
Yes.
Okay.
It's length times width.
If you haven't seen this, and I don't know if they introduced this in the early grades, even when they start doing area, side squared. A side is.
You can square it because the sides are the same length. So you can go ahead and do 3 to the second power, or 3 times 3, which would still be the length times the width.
Gotcha.
Okay.
Okay. So 3 squared, whatever the number of one side is, we know we can square it because all of our sides are the same. So 3 squared would look like that. And this isn't 3 times 2, so let's not get confused there. A lot of students do that when they do exponents. Okay? This is 3 times 3. 2 3s is what we need to see. The little exponent number tells us how many of the base number 3 we need. Okay. So it's telling us 3 times 3, which Ms. Jax just wrote over here. And 3 times 3 is?
9. So since we're going to do area, and I noticed that Ms. Sternberg is counting, let's go ahead and count and see how many blocks. Now, area covers the surface. So we're going to quickly talk about area, and then we'll just do a brief thing with perimeter, and then we're going to have to end because we're going very quickly.
Let's move quickly here to say, again, and I'm going to trace this outside here.
I like that.
I'm going to trace around here. It's not going to be a perfect square. It is perfect, but not perfect in my drawing.
As Ms. Sternberg is tracing, once again, the area is the part that's inside. It's the surface on the inside. So it's all the little tiles that we had here. It covers that shape. But the perimeter is the distance around the shape. And I don't know if we can go ahead and maybe do something like this with a different color.
And I wrote my 9 inside as I counted squares. So my area, and we wrote 9 over here, it's 9 square inches, or inches squared with a little 2 up there, or square SQ inches. You always have to put your label and know that we're counting squares or counting these spaces up here.
Okay, so once again, since we are ending, we have here
going around that perimeter. Going around the rim.
The perimeter is the area around this figure. So the answer for perimeter sometimes is the same and sometimes it's different.
Always, exactly.
Yeah, so let's go ahead and find out what our perimeter is. In order to find the perimeter, we need to add up every single side. So let's go ahead and do that. 3 plus 3 is 6, plus another 3 is 9, plus another 3 is 12. So this is different. Our answer for perimeter here happens to be 12 inches, and it's not squared.
Because we're not counting the squares, we're just counting the sides, the length, and length only has a single unit for measurement. And again, Ms. Jack said covering, when we're putting carpet down or tiles down, we're using that area. When we're putting up a fence, putting border around the room, we're using our perimeter. Okay. And we've used a lot of stuff. We've covered a lot of material today. I hope we didn't throw too much at you, but that we gave you some review things that you can think about and look at. And I think we're done.
I think we are done. So once again, remember, for the show that's coming up, if you have any questions, you can email them
Type them in. Get ready.
The intermediate show will be coming up shortly, and we'll be ending in just about 1 minute. So don't forget, let's look at the bottom of your screen. The email address is COU@pgcps.org.
Got it.
And the COU stands for Count on Us. And we thank you for tuning in to our Fast Review show.
And for Ms. Jackson and myself, remember that you can always count on us.
Frank, and I'm here with today's mini lesson on elapsed time. Elapsed time is when we find the difference between the start time and end time of an event, such as a game, a movie, a race. So I'm going to work on one word problem with you and show you how I would solve it, and hopefully that will help you solve elapsed time problems in the future. So let's take a look at a problem. This problem is about my friend named Melanie. Melanie was going to the movies. She went to a movie that started at 10:30 a.m. So I'm going to go ahead and I'm going to write down the start time. 10:30 a.m. The movie was 3.5 hours, and we want to find out what time the movie finished. So what we're going to do is we're going to start with our start time, and then we're going to count on the hours first. When we're finished counting on the hours, we're going to then switch to counting on the minutes, which is often what I like to do with elapsed time. Start by counting on hours until we can't add on any more hours, and then we switch to minutes. So let's take a look, and we're going to use a clock. And I preset the clock to 10:30 so that we were ready to go. So let's take a look. We're going to start at 10:30, and we're going to add on 3 more hours, and then we'll worry about the minutes later. So we're starting at 10:30. 1 more hour gets us to 11:30. 1 more hour gets us to 12:30. And then our third and final hour brings us to 1:30. So let's go ahead and write that out on our problem, and that way we can see exactly what we just did on the clock. So we were starting at 10:30 a.m., and 1 more hour brought us to 11:30 a.m. So that's our first hour. Then we went from 11:30 a.m. to 12:30 p.m., and that was our second hour. Notice how I went from a.m. and p.m. because we were at 11:30 a.m. So the next hour would actually be 12:30 p.m. So be very careful to look at your a.m. and p.m. when you're working out a problem to see if somewhere in your problem you're switching between a.m. and p.m. Be very careful. We then went from 12:30 p.m. and we added on our third hour, and that brought us to 1:30 p.m. So there, we added on our 3 hours. We then need to go back and add on our half hour. Since an hour is 60 minutes, then a half hour is 30 minutes. So let's go back to our clock and add on 30 minutes. So we are here at 1:30 p.m. So let's count by 5s and add on our 30 minutes. 5, 10, 15, 20, 25. There's our 30 minutes, brings us to 2 o'clock. So let's show that on our problem. And we were at 1:30 p.m. And then our half hour brought us, to 2 o'clock p.m. And that was our 30 minutes. So let's take a look. We added on our 1, 2, 3 hours and 30 minutes, and that brought us to 2 o'clock p.m. So Melanie's movie ended at 2 o'clock p.m. So whenever you're working on elapsed time, remember to start by counting on your hours until you can't add on hours anymore, and then switch to adding on your minutes. And that will hopefully help you find elapsed time in the future. If you don't have a clock at home like I had here, you can always draw one on a piece of paper. Start by drawing a circle. Put your 12, your 6, your 3, and your 9. Put the other hours in between, and then at least you'll have a visual that will hopefully help you add on your hours and your minutes for elapsed time. Thank you so much, and stay tuned for some more Count on Us. Have a great afternoon.
Across America, Service Learning is helping students improve their grades and their communities. Service Learning makes school exciting by connecting the classroom with community service projects.
Before Service Learning, I was just an ordinary student causing mischief during class. After Service Learning started, I got so involved into it, I started paying attention more, picked up my grades.
Okay, very good.
Service Learning absolutely drives academic success.
Working together, students solve real problems, build new skills, and apply their knowledge in a whole new way.
The great thing about Service Learning is it gives you this opportunity to go out into the world and do things hands-on.
Inside the classroom and out, Service Learning opens new doors and brings learning to life. Service Learning can make a difference in your school. Visit Learn and Serve America at learnandserve.gov to find out how.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Good afternoon. Welcome to your second half of Count on Us. I'm your co-host, Mr. Pugh.
And I'm Ted Herman from the great state of Maryland, Mount Rainier Elementary School. We're here to answer all your math questions today and anything on your mind that relates to math.
Well, unfortunately, we're unable to let's take your questions today because our phone lines are down right now. So today we are focused on Fast 2 review. But you can also email us at COU@pgcps.org, and we can answer any of your questions via internet tonight, live on the air. So remember, you cannot call us tonight, but you can send us questions at email us at COU@pgcps.org, and we can do some of those questions. But tonight, Mr. Herman and I prepared certain questions for Fast 2 review tonight. So how was your day today, Mr. Herman?
It was awesome.
Well,
how was your day?
Oh, my day was tough.
Tough.
Long Monday morning. Getting the kids back in the groove of things.
Routine, getting in the groove.
Yeah. And waking up so early in the morning in my school.
Oh, what time do you all start?
We start at 7:30.
And that's middle school?
Yes, sir.
Oh, that's rough. What time do you get out?
2:50, 3 o'clock.
See, that's math right there. 7:15 to 2:45. Elapsed time. That was my own thought. Thank you.
Somebody in my ear just told me that. Okay, I have a question for you. I know in my 7th, 8th, I have 6th graders in my building as well this year, 6th, 7th, and 8th, and looking at my Fast 1 data and looking at the data based on their assessments, weekly, quarterly assessments, I noticed a trend in my building. The algebra.
Some things increase or decrease, trend or stay the same?
About the same comment. Thank you, Mr. Herman. He's awesome. I don't care what your wife say.
Try to add.
So what I'm going to do now, we have focused on algebraic expressions and algebraic equations. So I'm looking at algebraic equations right now for the first time.
Oh, that sounds very intense.
All right. So and it's kind of simple. I have 2 problems I wrote down previously, so we're going to work on right now. So let's look at the first one. And I try to combine more than one skill at a time with my kids. So I try to compact my curriculum so kids can see things when they come up on the test. So I say 2x plus 9 minus 8x equals 51. Now, as you see, I already looking at this problem, my students should already know I got to solve for my variable x.
Right.
But also, they should also know now this is more than solving or multiple step problems. It's also combining like terms.
Absolutely. So
I see that these two are the same variable.
Oh, cool.
And you must apply the sign in front first. So let's put those together first. So that gives me negative 6x plus 9 is equal to 51. So at this time, I always tell my students to follow steps. It's a step process that we follow. I always tell them the first step is separate the equation into 2 parts.
Oh.
Identify your variable. How are we going to isolate x? That's my variable. What's on the same side as x? So now I'm going to use this word we always use in school. It's called inverse. Now, inverse means to undo something, but I also we use the word opposite. That's easier for kids to remember.
Oh.
Opposite. So if I see a positive 9 on the same side of x, what's the inverse of positive 9? Which is what? Negative 9. So that's negative 9. But what I do to one side, I must do to the other. Now, at this point, I teach my kids a property, because this is a mathematical property, which is the subtraction property, and here's the key, of equality. Because equality means I want to keep it balanced. What I do to one side, I must do to the other side. And since I'm subtracting both sides by the same value, that's why it's called my subtraction property of equality. So I draw my line. 9 minus 9, I undo it. It's my inverse. That drops down. Negative 6x is equal to 51 minus 9. I believe that's 42. Is it 42?
I would say 42 is a very good idea.
Because sometimes, if I'm not sure, I ask a partner, my parent, or my teacher. It's always good to ask someone who knows a little bit more than you.
No such thing's a bad question.
And Mr. Herman, you're a great guy.
For you, Mr. Pugh, I'm here.
Now,
I got your back.
So I have negative 6x equals 42. So now, what I'm going to do now, I'm going to divide by my coefficient. I love using those mathematical terms in my classroom because those are questions of vocabulary they're going to see on the test. I'm going to divide both sides by my coefficient. My coefficient is -6. Now, most kids get this confused and just write 6 because I'm not solving for my negative variable. I'm solving for my positive variable, x. So I'm going to divide because the inverse of multiplying is division. So I divide both sides by -6. And these -6's undo each other, which means they cancel out. It leaves x by itself, which is equal to 42 divided by -6. We all know a negative and a positive leaves me a negative. I only got to worry about the computation part. I already know the sign part. And 42 divided by 6 leaves me 7. So x is equal to 7. Now guess what? I just explained my work, and I didn't use any words or symbols. Now, let's say if the question asks me to justify. If I want to justify this response, I'll go back and show or check my work. So if I was justifying the same question in a BCR or ECR, students out there, this is what I would do without using any words.
I'm sorry. When you say justify, that's because you work at Ernest Just?
Oh, wow.
You justify.
I'm
you
justifying.
Just.
I'm justifying
you just. Justified.
Because just is #1 middle school.
Oh, my Lord.
Ernest Just is in the building.
That's incredible.
Let's show you how we justify this question
wonderful.
before I go to the next question. Or let Mr. Herman do the next question.
I'm impressed.
I'm impressed as well. So therefore, I'm going to take my solution as another key term. Oh, my gracious. I'm using all these great words. And everywhere I see x, I'm going to put -7. Can I do that?
Yes.
So I have 2 times -7 plus 9 minus 8 times -7. It should all equal 51. I'm going to say 51 real quick over there. You probably can't see it on the TV screen, but I'm going to work it out anyway. So 2 times -7 is -14 plus 9. -8 minus 57. It was what?
That'd be positive, wouldn't it?
Would it be positive 56?
Well,
positive
if you got
56,
a negative and a negative.
Equals 51. Thank you. You always say to help me out, Mr. Herman.
I'm here.
Okay.
I'm here.
So what's -14 plus 9?
That'd be -5, I believe.
-5 plus 56 equals 51. What's -5 plus 56?
Well, that's the opposite of that. So you got to subtract. That'd be 51.
So does 51 equal 51? Check. I just justified my solution. And so this is how one way we can do combining like terms by using our two-step equations in the problem. All right?
Well, I have to say you Ernest Just justified.
And
Ernest Just justified.
I have more problems like this coming up. I have probability questions coming up. And I also have multiplying those polynomials together, simplifying polynomials.
Because you're so special, Mr. Pugh, you go right into our drawing today.
Oh, yeah.
Which means you have the first chance of winning.
Don't be jealous.
Absolutely nothing.
Don't be jealous because I get to win a prize today. Don't be jealous.
Because if you win something, that'd be called nepotism or collusion or some kind of illegal practice. We can't do this.
Tonight.
We can't be on the air and win a prize. It's only for our great students out there to win the prize.
I'm a student.
But I'd love to go right to the next problem.
Yes.
And this actually came off of a recent. I hope you know that at I don't know. I'm sure you have at the middle school and in the senior highs level too. But at the elementary level, we also do a thing called tests.
Mm-hmm.
And to get ready for the FAST test, we do a special thing called a competency test to make sure you've gained the skills necessary to prepare yourself for the FAST test coming up. And the FAST test we're doing right now this week, we have taken these competency tests to make sure the skills have been mastered properly. Okay. So this came right off of one of our competency tests, okay, out of the core curriculum standards. And what this is a typical misstep on our students' part. So let's look this over and see if we can make sure we don't have any more missteps and we can get rid of all these little problems so we have less problems when we have a problem. You know what kind of problem I'm talking about? I'm talking about a problem here.
A problem is a problem.
The problem is the problem.
The problem is the problem. You have a problem with the problem.
I have a problem with the problem when it's a problem with the problem.
I don't even understand the problem because the problem is the problem. It's a problem is the problem.
That's the problem. But I understand from what you did the first time on your first lesson just now, I understand that math is rich with vocabulary. I learned a lot just now watching you in action, Mr. Pugh, because I understand that the vocabulary you expressed was excellent. Combining like terms, getting your variables isolated. All those kind of things are critical to our success. So look at this problem over right here. This is a line plot with the X's to show you how many times something happened when you had something going on in this problem.
Yes.
Video games were owned by these people. They did a survey taken from 4th grade classroom to see how many video game students owned. Now what this shows is 0 people had how many? 3 people had 0.
Yeah, 3 people had
3 people had 0 video games. So I'm glad you jumped on that and got me straightened out. But this is saying what?
That says that 4 people had 1 video game.
There you go. How many people had 2?
No people in the class have 2.
Nobody had 2 video games, but how many people had 3?
1, 2, 3, 4, 5, 6, 7, 8. 8 people had 3 video games.
Man,
Mr.
you're
Herman.
getting excited, Mr. Pugh. I love it. And how many people had 4 video games?
3 people had 4 video games.
Now, here's the trip. Here's the part that trips people up so many times. How many students own more than 1 game?
How many own more than 1 game?
Guess what the typical answer I get? Guess what the typical answer I get for somebody who does not take the time to read the question being asked?
More than 1 game? I
Yeah.
say probably 4.
Yep. Oh my gosh. People out there in TV land, 1, 2, 3, 4. He just did on purpose the typical mistake that some students will do when they don't read the problem carefully enough, Mr. Pugh.
Yes.
And what they'll do, I think, they put their own brain into the problem and say, I think I see what's going on here, when they really, in reality, don't see what's going on here. To say more than 1 game, tell us straight, Mr. Pugh, what are they actually supposed to look at? This column, that column?
No, they're looking at the numbers at the bottom of the number line. So I'm looking for any number that's more than 1. Like 2 is more than 1.
Right.
3 is more than 1.
There you go.
4 is more than 1.
There you go.
Yes.
And I think you said there was 8 here on 3 video
Yes,
games.
yes, sir.
And then 3 more.
Yes.
What's that total up? 8 and 3.
9, 10, 11.
Oh my gosh, he's gifted. He's gifted, and he justified his answer. He justified it just now. So how many students own more than 1 game? 11. Not the 4 that some people who are not paying attention to the problem. So I know Prince George's County students don't do that kind of mistake. They're much more worthy, and they're much more careful about what they're going to answer. That's all I got to say.
You want to do the next question?
There
I like
are
that
20
question.
students in the class. How many did not answer the survey? Oh,
I like that one.
Yeah, I bet you like that
Because
problem.
they make the kids think a little bit.
Oh my goodness. There are 20 students in this class, the video games, but how many did not answer the survey? You know what I would do? What would you do? Would you count all the answers you see so far?
What I would do is count all my X's.
That's it.
Then let me know how many kids actually answered the question.
There you go.
And I know that's 3 and that's 8. That makes 11.
All right.
That's 4. That makes what? 15.
Yeah.
And that's 3 more.
Makes 18.
So how many more missing from 20?
19, 20.
So the answer is not 18, but the answer is
2.
2.
Oh, I get it. I get it.
gracious.
There you go.
That's like
That is a
reverse
good
thinking.
question.
Wow.
That's really comprehending the whole big picture there. I love that.
All right.
Well, since we're on a roll, you want to do the last one too?
Oh, no. There's a lot of questions in that one.
A lot of questions in that one?
I don't know if I can add
You
more
know, I
fast.
wasn't reading that well. These video games all cost the same amount, $25.
Is the total amount spent by the students owning 4 video games greater than $75? Please explain your answer.
Total amount spent by students owning 4 games. Oh, well, if each one's worth 25, what's 4 times 25?
100.
So, is 100 greater than or less than or equal to 75?
I think 100 is greater than 75.
Good. So the answer would be it's greater than 75 because you got $100 spent.
So if you only spent $75, how many video games did you purchase?
3.
Wow. How did you know that?
I guessed.
You guessed? Awesome guess.
But I also multiplied 3 times the 25.
Oh, could you divide it 75 by 25?
You could have done that too. Could have divided, because isn't multiplication division inverse?
What? Inverse? He just thought that up.
The magic word just came down. Inverse again. Wow. I'm going to combine your like terms, buddy. I'm telling you right now. I love it. He's justified.
All right. Let's go to another. I was going to do another
It's all back
algebraic
on you.
expression.
It's all back on you.
But I'm going to change to probability. Even though we taught probability early in the first half of the school year, and I know it's going to be on the Fast 2 again, because that's one of those indicators that's always popping up. On every single test we take in this county, probability is always popping up. And And I developed 3 or 4 excellent questions about probability. So let me see which one I would like to use. I have a special lady in my life. Her name is Regina. And I wrote a question basically straight for Regina. It says Regina flipped a coin 25 times. Here are the results. Here's my outcomes. What was her probability of flipping tails? It says show your response. Oh, I'm so sorry. Show your response as a decimal, fraction, or a percent. So I don't know. Those were 25 times that Regina flipped a coin. And I want to know how many times she flipped tails. So I'm going to count. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. She flipped the coin she flipped tails 12 times. So I know she flipped it 12 times over a total amount of times of 25. Let me let you know this before we start. This is called experimental probability. Because she actually conducted the experiment. She actually flipped the coin. I think she chipped the nail too as well, so she need to look at her right thumb. Okay. And so I know it says show it as a fraction. Here's my fraction. So now I have to show it as my fraction, and I have to show it as a percent and decimal. So I'm going to show it as a decimal. And I always tell my kids, remember fractions are nothing but division problems, correct? So therefore, I can say 12 divided by 25. So I'm going to divide 25 into 12. And I know 25 cannot go into 12, decimal point, add a 0. And I always tell my coins, 25 is like quarters. How many quarters can you get close to $1.20? 4, because 5 would be too much. So 25 going 120, 4 times. That gives me 100. How many quarters to make $2? 8. 0. So now, press. Okay, press. Okay, let me finish my thought, please, because I know I did everything correctly. So
who you talking to? Me?
I don't know.
I didn't say nothing to you.
I know you said anything to me.
I'm trying to be. I'm supporting you.
You mentally send me mental thoughts.
Oh, like Miss Cleo.
Yes. So my decimal is 4800. I would say 0.48, but I know I get my ear cut off, so it's 4800. Okay. So now I have to show it as a.
He going for the Van Gogh.
As a percent. Okay. But we all know 4800s. When you tell me 48 over 100, because we know percent is always based out of 100, which is equal to 48%. Or some people know how to move the decimal point. 2 times to the right, which also gives me 48%. So I showed my outcome 3 different ways: fractions, decimals, and percent. Okay. Thank you so much.
Anytime I can help out.
Now, we can always do another problem. We have plenty of problems. Do you have another problem you want to do, Mr.
I'm sorry.
Herman?
I missed that whole conversation. How do you pronounce that answer?
4800s.
Okay, because this is the what? The tenths?
That's the tenths and the hundredths. I don't want to, fly stuff on, but tenths and hundredths. Because I have a special speech, my tongue,
Yeah,
so
you just cleaned my windshield. Thank you.
I'm so sorry.
My eyes never be the same.
Great job.
That was awesome.
That was a question I just made on top of my head. Thank you, Regina, for that question.
That
You're
was
awesome,
great.
Regina. Good
and
job.
Regina's really good at flipping coins. You ever seen Regina on the street flipping coins? She is unbelievable.
Unbelievable.
They spin exactly
Unbelievable.
perfect.
I believe I'll get to her school later on. Templeton Elementary. She's awesome.
Nice plug. Okay. Well, this question is a brain teaser. So you like
I'm not good. I'm not good at brain teasers. So this is all on you, Mr. Herman.
Well,
I don't want to get in trouble.
I'll use whatever brain's left in my body here.
I have none.
Well, you're doing better than me then. Okay. This is about four people named Pat, Sam, Kim, and Kyle. Man, do I love working with Mr. Pugh on the show because you get a chance to really relax and just show it off.
Enjoy yourself.
Show it off. Because math is all about enjoying it.
Everybody enjoying math. Having fun with math. Math can be fun.
You can't get stressed out by math.
You can't be stressed over
math. You got to
math.
enjoy the math.
And that's what Regina told me in her question, her email question.
What was that?
Because that question came from the email corner. And it's about having fun and laughing, enjoying math. And she said she likes to enjoy math.
That's great. I'm glad to hear that. Yeah. Pat, Sam, Kim, and Kyle were playing in the snow. And they were making snowballs to build a fort. So they were trying to build a wall of defense to make sure these snowballs protected them. Now, here it goes. We're going to create a chart to show the following. Pat has half as many snowballs as Sam. Kim has 3 less than Sam. Kyle has 1/2 as many as Pat. How many do they have in all? Now, what's in all mean to you? Anybody? Anybody out there? Hey, Mr. Pugh, what does it all mean to you?
What?
The words in all. How many did they all?
All together. How many total snowballs?
All together. There you go.
Yes,
total. All together.
I told you I'm not good at brain teasers. Please
no,
but
you're making progress. That's all that counts in life.
That's all that matters.
Show how many snowballs each person could have. Now, here's the deal with this problem. Before you get all bent around and start working, they use a very popular expression now called wrapping your mind around it. Well, before you start wrapping your mind around this problem, let's do a little analysis. There is no total. There is no total number of snowballs, which means we can't really verify or justify or have an exact number of how many snowballs there are in this problem. All we can do is pick our own number and then play with that. So I'm going to pick the number 12. You know why? Because I've already tried this problem in my mind a little bit, and it works out. But it doesn't have to be 12. It could be 10. It could be 8. I'm usually going to use an even number because it says Pat has half as many snowballs. So the fact that it says half as many snowballs, I didn't want to pick an 11 or a 9.
But 12 is the total number of snowballs you're talking about?
I'm saying, I'm going to say the person who has the most snowballs has 12.
So Sam has 12.
Thank you.
Thank you.
Thank you. That's what I'm talking about.
Snowballs.
This man's catching.
Snowballs.
He's snowballing me right here. Okay.
Snowball.
So here we go. Sam has the most. Sam's at the top of the list, and he has 12.
12.
How did I pick 12? I just picked 12 out of nowhere. It's an even number. Had I picked 10, then I got a problem. Because then somebody's going to have half. Who has half? Kyle, Pam, Pat has half. If you divide that by 2,
that's 5.
That's 5. How are you going to have 5? I guess you could have 5.
But Kyle has half many as Pat.
Yeah, the half of that 5. How's somebody going to have 2.5 snowballs?
They didn't finish making a snowball yet. It's a half a snowball.
Yeah, but you know what? That's complicated. Because what's a half a snowball compared to a whole snowball? It's all a matter of feel and judgment. It's perception. So we're not going to go with a 2.5.
It could be a mini snowball.
Well, let's not go there, okay? Because you're really making me more. You know what? You told me you had limitations on these problems. So don't make me more limited than you are, okay? So here we go. So Pat has half as many. So what's half of 12? You are 6. I love this guy. And then Kim has 3 less than Sam. So 3 less means what?
9.
Right. How'd you do that?
12 minus 3.
Right. 12 minus 3 is
9.
9. And then, oh, wait a minute. That's Kim. So I better label that.
Then Kyle has
they use 2 K's.
1/2 of Pat.
Kyle has 1/2 of Pat. So what's 1/2 of 6?
3.
There you go. And then it says how many they have all together. All you got to do is total up your numbers. So we're going to go 3 and 6 make what?
9.
And 9 plus the 9 make?
18.
And 18 and 12 make?
30.
Oh my gosh. 30 snowballs. Bing, bing, bing. You get your name in the drawing again for no reason because... What? We have a what? We're going to have a break after this because we've had so many phone calls. We can't get to them all today, okay? But we'll get to them in like 2 weeks, okay? When all the phones are working great again. So stay on the line and do the email corner coming up right now. And email us anything you want because we're going to come back after a break with more show.
And I guarantee after the break, we answer all your email questions at COU@PGCPS.
All right.
.org, all right? See you after the break.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
At this moment, across the country, families are packing their bags for a getaway. And no matter where they end up, they'll all be home by dinner. Plan your own at playgolfamerica.com. From finding programs in your area to finding advice from PGA professionals, playgolfamerica.com has a way for you to get away. Visit today for details. playgolfamerica.com, your link to the game.
It's easy, Grandpa. Brush your teeth twice a day. Floss your teeth once a day. That's a way to fight decay, hey, hey. Brush and floss every day, hey, hey. Healthy smiles are the way, hey, hey, hey.
You can keep your smile for a lifetime, even a boomer-saurus like me.
Boomers, you gotta love them.
And welcome back to the second half of the second edition of Count on Us. Once again, I'm Mr. Pugh.
And I got to get this word right in. It's straight up for the newsroom. Oh, hockey is back. This is for Dwayne Brown. Goal! Goal! And I'm Ted Herman from Mount Rainier. We're here to answer all your math questions you might have.
Now remember, our phone lines are down for this week. It'll be back on probably next week or check for Wednesday. But we're still answering questions via our email corner at COU@pgcps.org. And Miss Alexis, who's out there, I received one of your questions. And I'm going to answer that question right now for you, Alexis. All right, thank you for sending us the question. I know it's two more of you all sending questions in, but let's do Alexis first.
Great.
Alexis asked this question right here. It's a long question, but it's almost similar to the question I answered earlier. 6j squared times the quantity of negative 3j plus 3k squared minus 2k squared times the quantity of 2j plus 10j squared. Woo! I don't know what kind of math you're doing, Alex, but this looks kind of tough to me. That's a toughie. So I know the first thing I'm going to do, I think it's called distributed property. I'm going to distribute. Yeah. You understand? Yes. Distributed property. I'm surprised I can say that word, distribute. Wow. So I'm going to distribute these quantities. So I'm going to distribute. And I always tell my kids, I'm going to give you an example how I teach distributed property to my kids. Because I'm going to show you real quick. Who comes to your house every day, except for Sundays, no matter the rain, sleet, snow, sunshine? Every day, this person comes to your house every day. The U.S. what? Mail. The mail. He got a big old bag of mail. He comes to everybody's house. Nobody, if you live in an apartment building, or you in a business community, or you live on a farm, or you live in a house. He comes to each place and distributes the what?
The mail.
The mail.
I don't want to be rude to you, but what's this building right here?
That's an apartment, like a business community.
And that one?
An apartment building.
And that one?
Farmhouse.
How come they all look the same?
I'm not trying to be real clear. I'm trying to. He messing with my drawings.
That's very. I think drawings are important.
So therefore, 6J squared is my mailman, and I have 2 houses. My mailman must go to each house. So 6 times -3 gives me -18. J squared times J cubed. Because you remember, this is one of those problems where you have to compact your scales. So, you know, you're multiplying exponents or powers with the same base, you must add your exponents. J and J is the same base, so I got to add 2 plus 1, which gives me 3. So 6 times 3 gives me 18 again. But since K and J are not the same, I cannot multiply or add them again. They just leave me J squared, K squared. -2 K squared times 2J gives me -4 K squared J. Because once again, K and J are unlike terms, unlike bases. So you can't add the exponents or put them together. -2 K squared times 10J squared. That gives me -20 K squared J squared. Now I'm looking. I might be done. Can I simplify this algebraic expression? Yes, this is what it is. It's called an algebraic expression. I'm trying to simplify the algebraic expression. Why is it algebraic? Because I see many variables. It's an expression because expression is a mathematical sentence that contains a whole host of variables, numbers, symbols, signs. It has everything except for one thing, an equal sign. I don't see no equal sign, so I know it's an expression. So it's an algebraic expression. I see a common term.
You use some rich vocabulary.
I'm trying.
I love it.
I see a common term.
You enrich my life.
K squared, J squared are the same terms. So I can say 18 minus 20, which leaves me -2. Because I have K squared, J squared, I can add those together. So I could. But I cannot add these 2 together. There's no other terms, so I just leave those the same. So my final answer would be, Alexa, would be -18J cubed minus 2J squared K squared minus 4K squared times J. And I'm done my problem. I simplified the algebraic expression.
That's incredible.
Man. Thanks, Alexis, for that question. You made me sweat a little bit. I'm glad we had a commercial break before we came back on, because it took a long time for me to solve that. Thank you, Alexis.
And I hope and pray Alexis is watching this show right now to watch her email question being answered.
I have another email question later on in the show for you.
Oh, is that right?
Yes,
well, can I go to something else?
Yes, I'll let you
totally.
go first.
I'm going to break this stride a little bit and try something totally different, off the wall, kind of perplexing problem.
All right. He likes these perplexing.
I love these kind of problems.
Perplexing problems.
Perplexing.
The
perplexing.
PP. The PP.
Perplexing, right? That's it. I'm going ahead because I got nothing to say. Cheryl bought a soda that cost 32 cents. Do you see that 32 cents right there?
Yes.
She paid with exactly 6 coins. Tell which coins Cheryl used to pay for the soda. Well, watch of this. Watch of that. I'm going to go ahead and make little columns right now. Here we go. I'm going to try my first approach. And remember, 6 coins total. That's as much as you can use. And you have to use 6 coins because of that word right there.
Exactly.
You know, you're exactly right.
Exactly.
Exactly. And you're justifying your answer, too. I love that.
Because I'm a just man.
You're just. You're just great.
I'm a just man.
So exactly means you cannot have 5, you can't have 7. You got to be exactly 6. And my natural instinct would be to go for the biggest coin I can think of.
Mm-hmm.
So let's go. What's the biggest coin you can fit inside 32? You know,
quarter.
A quarter. So we got 1 at 25 cents. 1 quarter, 1 25-cent piece. Now that may or may not be the right answer, because then we got to get up to 32 cents from 25. And if I do 32
So only 2 ways you can go from there.
Yeah, I can go minus 20, the 1/4. That leaves me with 7 coins left.
You have 7 cents left.
7 cents left, right.
5
7
coins
cents.
remaining.
There you go. There you go.
Be partners.
I'm going to tell you, that's why you're here.
Partners.
You're saving me. So how do you make 7 cents happen?
You use a nickel.
1 nickel. And then how much more?
And 2 pennies.
And 2 pennies. The trouble is, I've only used how many coins?
4.
Right, because it's actually not 1, here's a 2.
It's 2 1 cents.
2 1 cent.
Yeah.
And this is no such thing as a 2-cent penny that I ever heard, unless you're in from another world. Okay, so here's 1, 2, and 2 make 4. So we didn't make that right.
No.
I didn't do that right. It was not your fault. I mean, you're here to help me out.
I'm helping you out.
You're helping me out.
See, this is not a brain tease. I can help you with this one.
Yeah, but I had a brain freeze because I tried to put down a 2-cent coin. I've never even heard of that.
It's okay.
Let's go. Let's not use a 25 cent. Let's go with something else. What would you use?
You can use dimes.
Dimes. How many dimes can we use?
Let's use 2 dimes.
2 dimes. Let's try 2 dimes. And we already got 2 coins already. And that leaves us with what? 32 minus 20. So we got 32 minus the 2 dimes, 20. That leaves us with 12.
Yeah. That's good.
That's good. Okay, let's go with that. So far we used 2 coins. We don't want to use a 3rd dime because then we're already up to 30.
I used 2 nickels.
My gosh. Oh my goodness gracious. 2 nickels makes 10 cents, right?
Right.
All right, so now we're up to 10 cents. Okay, and that leaves us with 2 more coins.
2 more pennies. 2 pennies.
2 pennies.
2 1 cents.
2 1-cent pennies, right?
Yes.
As opposed to 2 2-cent pennies.
Right.
And that's 2 4. Bing! Can I have that bell? Can I have that bell? Because you deserve that bell. You deserve that bell. You followed through. I hope everybody saw how that was really called a guess
and check.
And check. You can guess one idea. If it doesn't work from there, you learn something, you can change your answer.
I love this strategy with solving word problems.
Oh, is that right? Use guess and check yourself?
All the time.
Then you are more advanced than I ever gave you
credit for. But this is almost like a table almost you use almost.
It's almost like a table. Woo! He's so rich with vocabulary. I'm telling you. Table or chart or whatever you want to call it.
Yeah.
Oh my Lord, it's coming out of your nose. You got so much good vocabulary. It just expounds out of your face, and it's just beautiful to watch you in action. And that's all I want to say about that 32 cents.
I'm going to get prepared for your next question.
Oh, okay.
I'm going to another question.
Let's get another question.
I know this next person was Daniel who sent in the question on our email corner. Daniel, I can tell you was on our state website, mdk12.org, because this question is very similar to one of the MSA practice questions on there. I'm going to write it down. Your question was this right here. Your question was 2/4 A plus 3/5 B plus 4/5 A plus 1/2 B. This question looks very similar to one of the questions on the MSA practice on mdk12.org website that I know I tell my kids to use many times before. So once again, and I like this question because many kids in middle school have a hard time with fractions or rational numbers because I don't know why. It's just a simple number. But many kids have a hard time. It's the same rules that apply when you first learn them in 3rd and 4th grade. Make sure you can't add or subtract any the fractions with unlike denominators. But they get nervous when they see problems like this.
Right.
Just break it down. So step number 1 I would tell my students on this problem is put together my like terms. Here's a circle A. Circle A. You always include the sign in front. Here's a square B. Square B. So I see that my squares go together, my circles go together. So what I'm going to do is rewrite the problem. 2/4 A plus 4/5 A plus 3/5 B plus 1/2 B. Now, like I just told you, step 2, we can't add unlike denominators, right? Since the places are the same, I'm not going to put these two together. But what's my common denominator? A 5 and 4, which is 20, I believe.
I'm just confused. I want to make sure I got this straight. You put the A's together. Is that what you just did?
Yes.
Okay, the B's over here to combine them like. Okay, I got you.
I'm combining my like terms.
I got you.
So now I'm going to find my what?
A common denominator,
Common denominator, which is 20.
20.
What did I do to 4 to get 20? I multiplied it by 5.
By 5, right.
So let me show it on paper because I don't want to confuse. But when I do downstairs, I must do what?
You got to do upstairs.
That gives me 10/20 A. Multiply that by 4 times 4.
You know what? Because if you're still downstairs and you're not upstairs,
Now
then you're nowhere.
Then you're nowhere. So that gives me 16/20A.
Mm-hmm. Vocabulary. Denominators and numerators. Whatever you do to denominator.
Yeah, do down the denominator. I do my numerator.
There you go.
Which is my denominator's downstairs and my numerator's upstairs. So, okay. So, now 5 and 2 have a common denominator, least common denominator of, 10. See, I helped him out earlier. He helping me out right now.
Right, I'm helping like a crazy person.
5 times 2, 3 times 2 is 6.
I just couldn't figure out how, if the phone lines aren't working, how come we keep getting so many calls in our ears? I can't understand how it's working.
So now I can add this together. That gives me 26/20A.
Right.
Plus 11/10B. Now you should leave a problem as an improper fraction. So you can chop this down if you like.
Oh yeah, it's overloaded up there.
It's
so is that
overloaded.
one, yeah.
Up there? It's overloaded in the numerator.
Improper.
That's improper.
Upstairs and numerator.
Yeah,
both
so
of them are
we
overloaded.
can break this down. Oh, I'm gonna switch it right here. So I'm gonna break it down over here.
I got you now.
So 20 going to 26 how many times?
One time.
One time. It gives me with 6 over what? 28.
Oh yeah, leftover. And that's not even simplified.
No, we're not going to simplify that later on. We'll do that
my
last.
goodness.
10 goes into 11 how many times?
One time.
With 1 left over.
With 1 left over.
B.
There you go. That's
so,
done. That
if you want to simplify this response.
I wish you would.
When you simplify this response, it look like this. 1 6/20 A plus 1 1/10 B. So my final solution would be, I know 6 and 20 have a common factor, which is what, 2?
I think 2, yeah.
To be 1 3/10 A.
Is that called a GCF?
1/10.
Called
Yeah.
a GCF?
B. And Daniel, that would be your response to this question. If you was paying attention, how you listening, because you just emailed it during the commercial. So I know you was paying attention and listening out there in our TV world. We have faithful listeners on this show. So Daniel, that would be your final response. So I'm going to tell you again.
Mr. Pugh, I would never disrespect your ideas, but tell the viewers why you can't add those 2 tenths together. Why can't you add those 2 tenths?
Oh, great question, Mr.
I thought we
I
had
didn't even see that.
Common
No, I
denominator.
didn't. And Daniel, you cannot add these 2 tenths together because once again, these are unlike terms. That's an A and that's a what?
Oh, right.
B.
There you go. You can't put an A and a B. It's like apples and bananas.
Apples and bananas. Where did he come up with these things? So, and that would be a type of question that would be on the MSA or the FAST 2, where they may add those together at the end.
Yes,
might throw you off a little bit.
That'd be rough.
But Daniel, remember, always put your terms together first. Use the shapes or symbols. I don't know what strategy your teacher like you to use. Put your like terms together first, all right?
And never go out in public with your like terms together. And never go out in public with your charged up phone in your hand. Because that's very important to have that on the set all the time. Okay.
You want to do another one or you want me to go?
I think you're doing great. You're on a roll.
You want me, do it again?
In fact, guess what the hot dog said to the mustard?
Catch
You're
up.
on a roll. You're on a roll. I'm sorry.
Let's go back to probability.
Yeah, we ought to.
And this question I made up again. I have another friend, and I'm going to read this question to you. My friend named Dwayne.
Dwayne.
Dwayne's a good guy.
The hockey master.
The hockey man, you said earlier, Dwayne. Woohoo, Dwayne! Now, my friend Dwayne and I went to, we were at a school earlier today. And he did this trick with kids. He flipped the coin 50 times.
50 times.
50 times.
25 times more than Regina did.
After flipping the coin 50 times, he landed on heads 23 times. And the question was posed. What was his experimental probability for flipping heads? Show your answer as a decimal. And repeat. Dwayne flipped the coin 50 times. After flipping the coin 50 times, he landed on I'm sorry, wrong question. He landed on heads 23 times. What was his experimental probability for flipping tails? Excuse me. Flipping tails. I want to know tails, not heads, tails.
Oh, well, couldn't you just take the heads and use that with the total?
So here we go. We're going to do that now.
Oh, okay.
So he flipped the coin 50 times, and he landed on heads 23 times. So that's 23 over 50. That's for what, though? Heads, correct?
Well, that's the heads.
But I'm asking, how many times did he, what was the experiment probability for flipping tails as a decimal?
Could that be,
decimal.
So couldn't that be the inverse? You're throwing heads versus tails. Could that be the inverse of your 50 or what?
So therefore, if I flip 23 times heads, how many times was it on tails?
I'd say 27.
It'd be 27 over what?
50.
But that could be one way of showing your answer. But I asked for the answer as a what?
Decimal.
As a decimal.
Oh,
that's not as a decimal.
That's not either.
And most people at this time will write this.
No, they would not.
Yes, they would.
No, they would.
They would put .27.
Oh.
2700s. 2700s.
But that doesn't say 2700. That's 2750th right here.
What? Say it again.
That's 2750th.
So people don't make that same mistake.
Oh, that's sad.
All the time.
I hope not.
So I can show my answer two ways because my answer is not 2700s.
No.
So I can multiply this by what?
2
over 2.
Oh.
To get 54 over what?
Oh, that's a numerator and a denominator being multiplied by 2.
Yes.
And now you got 54 what?
Over 100.
Which was how you say that?
5400s.
Oh, how you write that?
5400.
Oh my gosh, give it up. There, you see the joining the hands right there? Okay, there you go.
So when he flipped the coin 50 times and 23 landed on heads, and we trying to show what was the experimental probability for tails as a decimal, it was an extra step I must do after I found out how many times he flipped it on tails over 50.
I got you now.
And I got to get out of 100.
Absolutely.
Which is 5400.
Beautiful.
So therefore, his experimental probability for landing flipping tails was 5400.
And for the heads, you just double that up too and get 46 over 100.
For heads.
For heads.
Yes.
Oh my gosh.
That make you think a little bit.
I love that.
I'll make that question at myself.
You're challenging my brain for higher level here.
I try sometimes.
I'm telling you. I'm telling you.
I try. You want to do one more
I got something here. Unless you had another email, I don't want to get you.
Well, I have my own personal questions.
Oh, okay.
But you can do yours.
If you don't mind, I'll do this real fast and get out of the way.
No, just do yours real slow.
I'll do it real slow and get out of the way.
A few more minutes
Either way, I'll get out of the way. Okay.
Move.
The area of Ken's rectangular yard is 480 square feet. The yard, not a yard in measurement, but the backyard is 24 feet wide. What's the length of the fencing Ken will need to buy in order to fence in the garden completely on all 4 sides? Well, here's how I would approach this, first of all, Mr. Pugh, because you know all this stuff. If you're going to have a geometry type question where you have a rectangular yard, wouldn't it be a good idea to do what?
A picture.
Draw a diagram, draw a picture. I love it. And we call that DAD or DAP. Give me a little bit of that DAP. Draw a picture, draw a diagram. Dad, draw a diagram.
Come on, Dad.
There you go, Dad. And it said 24 feet wide, so we're going to put 24 for the width. And you can put 24 here, although it's not really necessary, because we're trying to find the area. The area is 400 square feet. 480.
Here, right?
Okay, 480 square feet. FT squared.
Let me make these things legible.
Oh, legible.
Yeah.
I'm not used to that.
Yeah. So this, you said this is 24.
24.
24 yards. And this is 480 what?
Square feet. That's the area. And the question is saying, how much fence does he have to buy total to fence in all 4 sides? So we're missing which side? Oh my goodness, your length, outstanding. And let me show you a little trick to all our viewers, and Mr. Pugh, I know you know this already. If it's 480 square feet, and you're already working with area equaling length times width. Okay, so since we have yards and feet up here, we got to adjust for that too.
No, it should be feet. So you didn't read the problem correctly, Mr. Herman.
I never said the word yards.
You did say yards.
I said the backyard. I was distinctly experienced about saying backyard, but somebody else put yards up there. And now I'm getting the ear. Okay? Area equals length times width. So length Length, we have to figure out the length is. And here's my trick, and thank goodness you corrected me on this because I really feel better now. 480, and we're trying to get length times width, and we already know that width is 24. So I hope you know some number. Well, let's just go. We want to get a 0 in the end, right? So what number possibly could make something times 4 make a 0 in the end? What number can multiply 4?
5 or 0.
There you go. 5. Oh, I hadn't thought about the 0. That's good. Well, let's go with the 5 first because now I'm really working overtime. Okay? So 5. Now we know 5 times 24. That's not going to be 480.
No,
so let's use a bigger number than 5. How about
25.
25? Yeah, 25 or 20 or 15. I'm going to go 25. And if we use our calculator real fast, 25 times 24, we get 25 multiplied 24 is 600. So that's way too high. Yeah. So let's adjust this. So not to 5. I like that idea with the 0.
Try 20.
20. There you go. And guess what? 2 times 24 viewers. What's 24 times 2?
48.
48, and you got to put a 0 in the end because we're actually using a 0 right there. Oh my! I would never would have thought about that unless you were here. So 20 here, 20 there, and then how you gonna get the total number of feet to buy for this fencing? Add those all up.
Real quick,
okay.
I like how you did that, but I'm gonna show you all something. How what I did earlier goes right into what he did with finding one of the sides for area. Because we know area is equal to length times width, right? And they gave us area and they gave us width. So I was solving for what? Length. Inverse operation.
Inverse operation?
So
oh my gosh.
If that's multiplied, what is the inverse of multiplying?
Division.
So I'm going to divide both sides by what? My W.
Oh.
So now for A, area, divided by my width equals my length. So if I say 480 divided by 24 equals my L.
And there's no guesswork. You're
no
definitely
guesswork.
Getting the exact answer
the
directly
answer.
through the mail
so
by the U.S. Postal Service.
Equal to L.
There you go.
But guess what? It's all the same math. It's math within math. Wow. Who would have thought it?
You did, because you're the one who said it. Oh. So obviously you must have thought it up because your brain said it out loud. That's incredible. I just saw a mystery. I saw magical stuff come out of your brain. It's wonderful watching you in action. What do you do for a full-time living?
For a full-time job?
Yeah.
I work as hard for my kids in Prince George's County public school system. All right. Well, at this time, normally we'll do our drawing for the out of the thing. I think I'm the only winner for tonight.
I think you might have a chance. If it
Mr. Pugh.
That's unbelievable. So what do you get for all this? Here, you get one square, a foam square, which you can use for any kind of operation in school.
I want to remind people, I know that the reading starts this week, January 10th, I believe, and math is next week. So please tune in this Wednesday and next Monday to help fine-tune your math skills for the FAST2 data. Please remind you to call in and try your best to answer any questions or things you might be unclear with. And remember, you can always send us an email at cou@pgcps.org.
And you know what else?
What's that?
You can always count on us, my man.
I think kind of early, though.
Well, you counted very well.